Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel. So today we're going to be working on episode 4 of the Power Rule series, and I'm going to be introducing you to a new question. And if you're somebody who consistently watches my videos, my series videos, you're going to observe that a lot of the time what I do is every single episode you have something new to learn, even though the concept is basically the same. It's just that I change up the question so that you'll be able to see the different kinds of questions that you could get whenever you're doing a particular differentiation rule or applying a particular method. So in this particular video, the first thing that we're given to solve is basically the fourth question of this series. So we're given 1.25 x to the fourth minus 3.75 x squared plus 7.92. All of this equals to the function y of x. So the function y of x is 1.25 x to the fourth minus 3.75 x squared plus 7.92, and that is the question we're given. Now, just like I did in episode 1 and episode 2, I'm going to do the same exact thing here. Episode 1, episode 2, and episode 3. I'm going to do the exact same thing in episode 4. I'm going to first of all introduce you to the different rules in order for us to properly solve this question. So, this is the first thing you have to know. Since we're dealing with power rule, of course, since this is a power rule series, we have to know how to apply the power rule. In this particular in this particular general statement, you can see that anytime we're supposed to differentiate a variable that has a power, the first thing we have to do in order for us to differentiate it is to first of all bring down the power. So you see you have x to the n. The first thing we're going to do would be to bring down n in front of x so that n becomes the coefficient of x or coefficient of the variable you are working with, right? And then you're going to decrease that power by 1. So basically, this is what you end up with. Now, let's do a quick example. If we're supposed to differentiate x to the fifth, right? So we're given x to the fifth, and we're supposed to differentiate this. What you're going to do is to bring down the power, right? Bring down 5 and make it the coefficient of x. And then you decrease that power by 1, and you end up with 5 minus 1. So you end up with 5x to the fourth, because the first thing you did, since you're applying power rule, is to bring down the power down here, right? And then reduce this power by 1, so you end up with 5x to the fourth. That's basically how you do power rule whenever you're given a polynomial or maybe a main variable to the power of something. That's the same that is going to apply no matter what you're handling. Doesn't matter if the power is a fraction, the power is a decimal, or the power is anything basically. So if we're given x to the 1.7, right? It's gonna just be, when we differentiate this, we're going to end up with, bring that 1.7 x, and then you do 1.7 minus 1. That's going to give you 0.7, and this is your answer. Now, the only thing that you cannot differentiate when you're dealing with power rule is whenever n is equals to 0. Whenever n equals to 0, you do not differentiate, because we need n to be a non-zero real number. So if n here, we end up with x to the 0, anything that is a variable or a constant to the power of 0 is always going to give you 1. So basically, we already know the answer is going to be 1. So n cannot be a 0, because we cannot basically we cannot work with that. But then so that's just one thing I'm trying to explain to you guys before we start. But then you may be wondering, what if x stays by itself? Now, anytime you have a power like this power that is here, and that power does not have, anytime you have a variable and the variable does not have an actual power, so it has an invisible power, so it's not x squared, not x cubed, not x to the 7th. No, like there's nothing here, there's nothing here, there's nothing here. What you're going to do is to understand that anytime there's an invisible power, that's telling us that the power is 1. So that is, the power is 1. It's like us dropping 1 in front of x to make x 1 to be the coefficient of x, and then to decrease that main power 1 by 1. So you end up with 1x to the 0. And what did we say x to the 0 is? We know that that's 1. So that's 1 times 1. So that's basically how you work with that. So yeah, that's the first thing I wanted to mention. So it's a good review. Now the second thing I wanted to mention is the sum/difference rule. And I know you may be bored because it's like, dang, how many times are you going to tell us about this? Well, I'm going to keep telling you guys because I want to assume every single person is striving and struggling. And the more times you hear something, the more it's going to be good for you to work with, because by the time you guys maybe advance to other calculus classes like calculus 2, calculus 3, it's only when you have a good grasp of the foundation, that's when you're going to have those differential equations courses and calculus 1 and 2 and all of this mathematics for science and engineers and all of those like higher level quantum courses. If you don't have a good grasp of differentiation, where you're not even going to be expected to do the whole differentiation out, you would not be able to do well in those classes. So that's it. That's the reason why I tend to go into detail, because they're all different kinds of students watch these videos. So this is this one. So now imagine we're given this basically the sum/difference rule. What are we doing here? What we're simply doing here is f of x plus g of f of x plus or minus g of x. This plus or minus is trying to tell you that in between the f of x and g of x, it could be either a plus sign or a minus sign. So it's not that you're going to say every time I'm giving something, I'm giving two sub-functions as a main and two sub-functions added, they have to be added and subtracted together. No, it just means that you could either have two sub-functions added to each other or two sub-functions subtracted from each other. And the truth is, you don't always have to have two sub-functions. Just for the sake of math, we're working with two sub-functions that way. So that's really what's good. So it's not like, oh, this is we're working with this one here and it has to be plus or minus. No, it's just saying that you're dealing with two sub-functions that could have either been added to each other or subtracted to each other. And the thing is, you're not just going to be dealing with two sub-functions. If you're given a question with a polynomial, like say x to the 5th plus 7x to the 4th minus 9x to the x cubed plus 17x squared minus 8x plus 16, right? This is also, you're going to also apply the sum/difference rule. The reason why we're just using 2f of x and g of x is just to be able to explain the expression in the simplest of terms, but the same application of the sum and difference rule can be used whenever the sub-functions are more than 2. So that's just one thing I wanted to mention. And then the last one is just basically constant multiplied by function occurrence, is where we have a constant, in this case k, represented as k, multiplied by a function. What you just do is, if you're trying to differentiate a constant multiplied by a function, you just have to bring out the constant and then multiply that constant by the differentiated value of the function. So you're going to see that in the next page. So if we're supposed to do, like, say we're given 5x squared, right? We're supposed to differentiate this, we're going to bring out 5, and then we're just going to focus on differentiating x squared. That is what this is saying right here. So this is another beautiful refresher for you guys. And yeah, I'm going to do this 10 minutes refresher, and then I'm going to go straight to answering the question. But there's nothing wrong with good refreshers. So now this is it. So 1.25 x to the 4th minus 3.75 x squared plus 7.92 y to the x. So the first thing we're going to do is to apply differentiation. So we end up with d of dx. So we're going to differentiate this function with respect to the variable, and the variable that we're dealing with is the variable x. So you have d of dx of y of x equals 1.25 x to the 4th minus 3.75 x squared plus 7.92. So we're going to differentiate all of this. So now this is basically the first thing. We're going to differentiate it. Now we're going to apply the sum / difference rule, right? Just like we explained. So we end up with d of dx differentiating y of x with respect to x equals d of dx of 1.25 x to the 4th, okay, then minus d of dx 3.75 x squared plus d of dx 7.92. If you remember what we did in the previous page, we split it. That's what is going on here. We split it into the sub functions. So now that we've done this, we're now going to apply the constant k multiplied by the function occurrence. So we end up with, let me continue with a beautiful green. So we have d of dx y of x was d of, so the next thing we have to do is bring out the constant. So we have 1.25 multiplied by d of dx of x to the 4th minus 3.75 d of dx of x squared, okay, plus, now the derivative of a constant is always going to give you 0. Just like the derivative of pi will give you 0, the derivative of 3 will give you 0, the derivative of 1 billion will give you 0, the derivative of 0.12 will give you 0, because all of those things that I've mentioned are constants. And 7.92 is a constant, so the derivative of 7.92 is just going to give you 0. So you have that. Now let's continue. So d of dx of y of x. So you have 1.25. Now we're going to apply the power rule. And now let me just do a good refresher, right? The first thing we applied here was the sum / difference rule. Then we applied the constant k multiplied by the function occurrence, so constant multiplied by function occurrence. So that's the second one. Now the last thing we're going to apply is this gorgeous stuff called power rule. So that's what we're doing now. So we end up with 1.25, and now we apply the power rule. We bring down the power of x to the 4th, so that's 4, and make that the coefficient of x, and then we decrease that power since that we've brought down by 1. So 4 minus 1 will give you 3, so 4x cubed minus 3.75, and we do the same power rule here that we're applying. We bring down the power of x squared 2, and we decrease, and we make that 2 to be the coefficient of x, and then we decrease that 2, the power of x squared, by 1, so you end up we end up with 2 minus 1, and that's 1, so that's that. And then d of dx y of x. So 1.25x cubed and all of this. So the next thing is going to be 1.25 times 4. If you use your calculator, you get that to be 5.0 and then x cubed, because what we did basically is to multiply 1.25 times 4. We're going to do the same thing here, 3.75 times 2. That's how you do the math. So 1.25 times 4 x cubed, because we're not just going to do 1.25 then we have a bracket for x cubed, because we already know that anytime we have bracket in mathematics, it just means we're multiplying it. So 1.25 times 4 is 5 x cubed. If you're doubting it, please use your calculator. Then 3.75 times 2 is just going to give you 7.5. Use your calculator as well, and then you have 7.5x. So basically this is the answer to the question that we did here. You can see the thing we worked on. We did the power rule here, sum/difference rule, and then constant multiplied by function occurrence that happened. Then when we applied it, we first of all used the sum/difference rule to break it down. Then we did the constant multiplied by function occurrence. Then we also did the power rule, and then whenever we did the power rule, we just multiplied by, if we did the coefficient, we just basically multiplied. And that the only reason why we multiply is because we already had stuff in front of x to the fourth, like the initial function had coefficients. So the x to the fourth coefficient was 1.25, the x squared coefficient was 3.75, so we had to multiply. But if these coefficients didn't exist, we wouldn't have anything at the front to multiply by. So basically this is your answer. Alhamdulillah Rabbil Alameen. Thank God we just finished another video. Hopefully this video was helpful to somebody and you guys understood what was going on. If you guys have any questions, please put it in the comment section. Please don't forget to follow my Instagram page, which is basically Muslima_tutoress, and that's my Instagram. I post quizzes weekly, and I also post updates about this channel and all sorts of fun stuff and make sure you watch my stories as well. So this is basically IG. So yeah, that's just one thing I wanted to mention. So if you guys love this video, please give it a huge thumbs up so that you'll be notified of more videos and my videos can blow up hopefully, and it can reach more and more people across. If you have classmates that are struggling, please share my videos with them, since alhamdulillah I go into detail. And please click on the notification bell so that you're always notified anytime I post a new video. And if you have any good suggestions, please write it down in the comment section. And if you have any personal questions or you need personal tutoring time, I also run a tutoring gig. So if you guys want help with that, just email me, and my email is going to be in the description box. So take care of yourself, and assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.